Hey there, class. Mr. Rusky here. Hope you're having a good day so far. We're continuing with chapter 10 today. This is 10.8, day 1. Today's lesson is factoring and finding the greatest common factor. Our essential question is, what is the greatest common factor and how do we find it? All right, let's get right into it. So this will be important for factoring by grouping, for different parts of factoring. If you recall, the greatest common factor is basically the biggest number that goes into two numbers. It's the greatest factor, basically. So we're going to be doing something similar to that today, but also we're going to be adding variables as well. Excuse me. So let's get right into it here. So what are the factors of 24 and 40? Go ahead and see if you can list the factors of 24 and 40. For example, 1 and 2 are factors of both of these. Why don't you go ahead and start with 1. So 1 goes into 24 and 1 goes into 40, and so does 2 goes into both of those as well. See if you can find the other factors that go into 24 and 40. Go ahead. All right, so 3 goes into 24, 4 goes into 24, and the way you can find this is just by doing 24 divided by 2, divided by 3, divided by 4 on your calculator. And if they come out to nice whole numbers, then they're divisible by those numbers, which means they are factors. So we also have 6 and 8 and 12 and 24. And also, each pair of factors is going to have a pair, right? So 2 times, whoops, that was bad. 2 times 12 multiplies together, 3 times 8, and 4 times 6. These are all the pairs of factors that multiply to 24. Factors of 40 are, we also have 4 and 5 and 8 and 10 and 20 and 40. Okay? This is, what is the greatest factor they have the same? So what's the biggest number that goes into both of these? Well, if you start here and go this direction, you can see that 8 is the biggest number that goes into both of these. So another way to say what's the greatest common factor that they have the same is to say, what is the largest number that goes into both numbers? That's another way to say that. And here's a trick that we need to be careful about is sometimes people see 12 and 18 and they try to say that, I don't know. Sometimes people try to say that, here's the thing. The greatest common factor can't be larger than the smallest number. So what does that mean? Very sloppy handwriting, but you get the point. So what does that mean? So basically, some people try to say the greatest common factor between 6 and 10 is 10 or something. So basically, if you want to find the greatest common factor, you can just find the factors of the smaller number, and whatever factor goes in, the biggest factor that goes of the smaller number that goes into the other bigger number, then that's how you can do that, right? Because you can't have, for example, 40, 24. So 40 goes into 40, but 24 does not divide by 40, right? So 40 cannot be a factor of 24, okay? So just be careful with that. I see students a lot of the time, they'll try to say that factors that are bigger than the smaller number are factors, which you can't do that, okay? So the greatest common factor cannot be bigger than the smallest number that you're talking about. So in this case, 24 and 40. 40 goes into 40, but 40 does not go into 24 because 40 is bigger than 24, okay? All right, we have some greatest common factors here. Why don't you go ahead and see if you can figure these numbers out. Give them a try. 1, 2, and 3. All right, the greatest common factor between 20 and 25 is 5. If you got 5, way to go. You can list out, 1, 2, 4, 5, 10, 20, and 1, 5, 25. And 5 is the biggest number that goes in both of these. Greatest common factor between 7, 21, and 28. So, 3, 4 goes into 21 and 28, but 7 is the smallest number. So the only factors of 7 are 1 and 7 because it's a prime number. So does 7 go into all these numbers? And it does. So see, by finding the factors with the smallest number, I can stop there. I don't need to find the factors of 21 and 28 because they can't, You know, if it doesn't go into 7, it's not going to work, okay? What's the greatest common factor between 5, 10, and 12? It's actually going to be, they actually have no greatest common factor because the factors of 5 are 1 and 5 does not go into 12. So the greatest common factor when there's no factors in common is just 1 because every number is divisible by 1. Okay, let's keep moving along. The greatest common factor for terms with variables. All right, so the greatest common factor on a variable is always the smallest exponent on each variable. Okay, so if we're looking at the greatest common factor for 30x to the third y and 20x to the fourth y to the fifth, so we're looking for the biggest number that goes into, let's write that over here actually. The GCF equals largest number and smallest exponent. The largest number and the smallest exponent. So what's the greatest common factor between 30 and 20? Well, that's going to be 10. And then what's the smallest exponent? We have x to the third and x to the fourth. Which one is smaller, 3 or 4? So we're going to put x to the third because it's smaller. And then we have y to the first and we have y to the fifth. Which exponent is smaller? Y to the first. So we're going to get 10 x to the third y. Because that's the biggest number that goes into 20 and 30. And the smallest exponent between x to the third, x to the fourth, and y to the fifth. All right, see if you can do 1, 2, and 3 on your own. Give it a try. All right, number 1, 8x to the third, 24x. What's the biggest number that goes into 8 and 24? Well, that's going to be 8. And what's the smallest exponent, x to the third or x to the first? It's going to be just x. X is going to be so it's going to be 8x is our GCF. All right. 25w to the third, 30w to the fourth, and 15w squared. What's the biggest number that goes into 25, 30, and 15? Well, that's going to be 5. And what's the smallest exponent, 3, 4, or 2? We're going to put w squared. All right, we have negative m to the fourth, p to the fifth, and m to the third, p to the seventh. What's the smallest exponent, m to the fourth or m to the third? M to the third is our smallest exponent. Which p is smaller, p to the fifth or p to the seventh? P to the fifth is going to be our GCF. All right, moving along. Factoring out the greatest common factor. How do you determine what goes in the parentheses? What you're going to do is after you pull out a GCF, you're going to divide each term by the GCF. And that's what's going to go inside the parentheses here, okay? So we have 20x plus 35, and our GCF is 5. So now I'm going to divide both of these by 5, and that's what's going to go in the parentheses, okay? So 20x divided by 5 is going to be 4x. And what's 35 divided by 5? That's going to be 7, okay? So basically what we're doing with factoring, I should have mentioned this, is that we're trying to undo distribution. So if you were to redistribute this now, you'd get back to this over here, okay? So we are going the opposite direction. Distribution is multiplication, and factoring is division. So we're going the opposite direction this time, okay? So why don't you guys go ahead and see if you can try 1 and 2 on your own. We're going to divide, so the GCF is in front of the parentheses, and now you're going to divide both or all the terms by the GCF, and that's what's going to go inside the parentheses. See how you do. All right, we have 24x to the fifth minus 28x to the squared, and our GCF is 4x squared. So I'm going to divide both of these by 4x squared. So 24 divided by 4 is 6, and then x to the fifth divided by x squared. Ooh, what do we do with exponents when we divide them? We subtract. So if we go like this, we divide by 4x squared. We're going to divide both of these, and we're going to subtract the exponents. 2 are going to cancel. We're going to have 3 left on top. So it's going to be 6x to the third. And then what's negative 28 divided by 4? Well, that's negative 7. And what is x squared divided by x squared? Well, they're going to cancel out and go to 0, so you can just keep it as 6x to the third minus 7. All right, next one. 5x is the GCF. We're dividing everything by the GCF. So 10x squared, 10 divided by 5 is 2. X squared divided by x is going to be x to the first. 25x to the third divided by 5x. 25 divided by 5 is 5. X to the third divided by x is going to be x squared. And then 15 divided by 5 is 3. And x divided by x are going to cancel out. And there's our GCF. Or there's our final answer. Okay? All right. Okay, so it says, how do you tell if you factored out correctly? And the way you do this is you look inside the parentheses and make sure that the terms only have the number 1 in common as a factor. And you can use a distributive property to multiply the problem back together. But we're just going to look at the GCF inside the parentheses here, okay? So the original problem was 8x to the third plus 16x squared, and they pulled out different factors in front, and we're going to check if there's a GCF inside the parentheses, okay? So I have this top left one here. What can we pull out of x to the third and x squared, or 2x squared? Well, there's no number they have in common. We can pull out an x squared. So this is actually not the GCF right here because there's actually more that you could have pulled out. You could have pulled out x squared as well. Down here, we could have pulled out a 2 because 2 goes into 2x and 4. So that's not the GCF either. So these are not the right ones. How about this one down here? We have 8x at x squared plus 2x. Well, in this case, we have an x we can pull out in common, right? The smallest exponent you can pull out of both of these is an x, so it's not this one either. Let's look at x plus 2. Is there a GCF we can pull out of x plus 2? Well, there's no number they have in common. This is a 1x, right? And this one does not have an x over here, so this is our GCF. The GCF here is 1, which means this is the correct factorization, so it's going to be this. It's going to be 8x squared times x plus 2. But if you do it right the first time, you don't need to worry about all this guessing and checking kind of thing, but if you do it right, there should be nothing else you can pull out besides 1, okay? Because it has the GCF taken out of the polynomial, or binomial. All right, let's do one more together, and you'll try a couple on your own. Factor out the greatest common factor. All right, so we're going to do number 3 together, and you'll try a 2 and 1 on your own. So we have 14x to the third plus 21x minus 7x to the fourth. Is there a number that goes into 14, 21, and negative 7? There's a 7 we can pull out of there. And then how many x's can we pull out? I see x to the third, x, and x to the fourth. Well, I can pull out an x. Now I'm going to divide everything by 7x. So what is 14x to the third divided by 7x? Well, that's going to be 2x squared. What is 21x divided by 7x? Well, that's going to be 3. And what is negative 7x to the fourth divided by 7x? Well, that's going to be negative x to the third. And if you wanted to, we're not going to do it, but if you were to distribute this again, you should get back to the original problem here, and that's what it means by check over here, but we're not going to do that. We don't need to worry about it, okay? See if you can do 1 and 2 on your own. Find the GCF and divide it out. Factor out the GCF by dividing. Go ahead and give it a try. All right. Is there a number that goes into 1w squared and 10w? No, there's not a number that goes into both of them. How about an exponent? What's the smallest exponent, w squared or w? We can pull out a w. And what's left when we divide everything by w? Well, w squared divided by w is w. And negative 10w divided by w is negative 10. All right. How about this one down here? We have 24t to the third plus 20t minus 36. What's the biggest number that goes into all 3 of those numbers? It actually is 4. It is 4. Now, what's the smallest exponent we can pull out of here? Well, this 36 does not have an exponent over here, so we actually cannot pull out any exponents. We're going to leave it like this. So now we're going to divide everything by 4, which is going to be 6t to the third plus 5t minus 9. And we can tell we did it right because there's no numbers we can pull out of 6, 5, and 9, and this one does not have an exponent. So that means that our final answer is going to be this. These are our answers. Okay. All right, that should be all I have for you today. Hopefully that makes sense. Remember, you're pulling out the biggest number and the smallest exponent, and when you pull it out in front, then you need to divide both or all the terms by that GCF, and that's going to go inside the parentheses, okay? Thank you for watching. Have a great day, and we will talk soon.